Hi, 12s. Welcome to exercise 11.1, where we take a look at the scheduling problems. So this is where directed graphs are involved, and there's going to be weighted directed graphs in basically every network that you'll see. What does it all mean? Well, essentially, it's just a network where there's a lot of vertices and edges that have directions. For example, if we zoom in on this start to finish directed graph on the right here, without reading too much of the blurb, let's say you had a bunch of holiday homework to do. Let's say with all these directed graphs, you actually have to do every single edge, all right, to get to the finish line, okay? Because, for example, if A here, this A edge is just maths, and this B edge is English, the math might take 7 minutes to do. The English might take 3 minutes to do. You have to do both math and English, because if you just do math, well, then you're technically not finished, because the English work still needs to be completed. So that's what a directed graph is. And so there's a way we figure out all these earlier start time and later start time that we do in exercise 11.2. But for now, just know that every edge needs to be completed for you to actually reach a finish. So it's not the quickest way from start to finish, and then you skip a bunch of English. Let's say this is artwork, this is IT work, PE work, and whatever. But what it actually means is to do your whatever work E is, you have to do A before that. Okay, for example, to learn exercise 11.2, you need to do exercise 11.1. Okay, so that's what these directed graphs mean. So how do we draw one? Let's take a look at an example. The best way to learn is to do. All right, you're going to get given a table where there's a bunch of activities A to G. All right, A looks like our starting time, and what we have in the middle column is activity time in hours. So activity A, whatever it might be, let's say it's maths homework, takes 3 hours to do, and there's no immediate predecessor, meaning this is your starting point. Okay, you're going to start with 3 hours of homework for maths. Let's say it's 11.1. Activity B takes 4 hours, and this needs activity A to be completed before you do activity B. So this could be exercise 11.2, and you need exercise 11.1 done, which was activity A. All right, and then activity C could be exercise 11.3, and this exercise takes 3 hours done. But you also need activity A completed, but not necessarily activity B, which was exercise 11.2. All right, so that's sort of the analogy that we're going with. So on and so forth, we're going to form ourselves a directed graph. And so, sorry about that. And so what we have here are a bunch of examples where we make different connections. And let's go ahead and draw it. So example 1, draw the directed graph for the activity table below. All right. So what we need to do is we need to draw our starting vertex. Let's call this the start, because that's what it is. And again, it doesn't matter if you go up to the top or to the bottom, to the middle. It's completely up to you. As long as the arrows and the numbers are labeled, you're in a good spot. So let's say we go to the second node. Activity A takes 3 hours. So we write this edge as A3. After activity A is done, we have to do activity B and C. And both of them require activity A to be completed. Okay, so we draw 2 sub-branches of activity A, the first one being B. Oh, also don't forget the arrows. Okay, so we got like these arrows branching off. All right, so activity B takes 4 hours. Activity C takes 3 hours. And then we put a vertex once the line ends. Activity D also takes, also needs to be done after activity A. So in fact, we've actually got 3 edges I thought activity C would have been just the last one. So we'll put activity D in the middle. Usually be A, B, B, C, D, but doesn't matter. Again, the order, as long as we've got the same number of edges coming off the vertex, then we're okay. So D takes 8 hours, not 3. Whoops. D takes 8 hours. And then we move on to E. E takes 3 hours and needs activity B done beforehand. So E would take 3 hours. And needs activity B done beforehand. F requires activity C to be done, and this takes 5 hours. It's good to keep, the lines and dots in proportion so it's not going everywhere. I mean, you don't have to, but it just makes my life marking it easier. So F takes 5 hours. And then the very last one, G requires E, D, and F all completed. So let's say G is here. And G takes 7 hours. So what we notice is we actually need ourselves a central node. So because G needs E, D, and F, lines E, D, and F needs to meet at a central point. So we need to use our pencil and rub it out. And we have a central point. So the central point looks like this. This is line G. 7 hours. And what we have is line E, which took 3 hours. We had line, which one was coming from C? Line F, which took 5 hours. And then this D line needs to be extended. It actually worked out all right that D was in the middle, because now we can just split this right through the middle. All right, sometimes it doesn't end up like this, but that's okay. Screw. So what was D? D was 8. D took 8 hours. And it makes sense, right? Like B and E you do in 7 hours combined. D here takes 8 hours. C and F takes like 8 hours. So, the lines are pretty proportional here. And then the last one is G, which requires E, D, and F to be completed. And that's why they meet in this central node here. Alrighty, that's example 1 done. Let's take a look at reachability. Reachability, exactly what you think it means in English. When you're reaching for something on a shelf, you either can reach it or you can't. Okay, and that's reachability depending on your height. Here, what we're talking about is the ability to get from one vertex to another in a directed graph. So if we're talking about the reachability for this directed graph on the right, determining which vertices are not reachable from vertex C, what we need to do is we just got to follow the arrows. Okay, so we essentially start at vertex C. All right, so the question says from vertex C. So we start at vertex C. We can't go to B because the directed arrow is B to C. We need to go to D so we can reach the vertex D. We can also reach the vertex G, but not any further because F and E go to G. We can't go from G to F because the arrows pointed the other way. We can also go from D to E and then E to B. So from C, we can get to B via D and E, but we actually can't get to F and A. So which vertices are not reachable? Vertices F and A are not reachable from vertex C. All right. Hopefully reachability makes sense. You just follow the arrows. If the arrow points you the other way, you cannot go there. Dummy activities. This is probably the hardest one to comprehend without doing 11.2, where we take a look at earlier and the latest start time. But dummy activities essentially need to be added to a network to ensure that no two vertices are connected by multiple edges. For example, if we have whatever activity C is flowing into activity D and E, which ends up flowing both into F, we cannot have this situation because D and E likely take different times. And so what we need to do is, again, it doesn't quite make sense without 11.2. I promise you this will make sense in 11.2. What you need to do is you need to branch either D or E off to a dummy vertex and then draw a dummy line, a dummy edge to activity F, or the start of activity F. Okay, all that means is activity D might finish earlier than activity E. So let's say activity E is to do math homework, and that takes 10 hours. Activity D is to do English work, and that takes 8 hours. In the meantime, once you've done your English work, you might not be able to start your next activity. Your next activity might be going outside and hanging with friends because your parents say you have to do your math work, you have to do your English work before you go and do activity with F, which is hanging out with friends. And so once you do activity D, you can't go straight to activity F as implied in this incorrect network because you haven't done your maths yet. Your math, you still got 2 hours left to do activity E, which is your 10 hours of maths. And so that's why you need a filler for your dummy activity for that 2 hours where you're still doing your math homework. So let's say you're multitasking because you're a genius. All right. I promise you next exercise it'll make sense. But just know that for now, two edges can't run to the same starting point. Okay, you need dummy activities. So how does that look? Well, it could also look like this. If we have a table where we've got activity F and G, where activity F needs activity C, D, and E done, and activity G needs activity E complete, we cannot have F and G branching off the same vertex, where we've got C, D, and E all branching to, I guess, activities F and G. All right, what we need to do is we need to separate it where we have C and D, okay, go into activity F because G doesn't need C and D to be done to begin. All right, you only need E to begin. All right, so if you're working in project managing in your later years, this will make sense. For example, you could be operating or managing a workplace. Let's say the workplace is building a car. You need, let's say, the base, the wheels, before you can start putting in like the interior. Okay. Whereas activity E to activity G might require something completely different, like the door attaching to the shell of the vehicle. But obviously the door will still need to be eventually attached to the base. Actually, no, that's a terrible example. Anyway, we'll come back to it next topic. There's plenty of examples that we'll go through. But for now, just know that you need dummy activities if one of the activities don't require the previous predecessors. Okay, you can just move on and the dummy activity will take care of it. Because this here says C, D, and E needs to be done before G can begin. That's wrong. Only E needs to be done before G can begin. Right? C and D doesn't matter. That's a dummy. Right. So let's have a go at drawing these dummy activities. We start at, actually, did we write finish? I think we forgot to write finish in the last diagram. Yeah, so. Oh no, what did I do? Nothing. Good. Right, let's get back to it. All right, draw the directed graph for the project shown below, including dummy activities where required. So let's say this is our starting point, because we like to start left to right. If you start right to left, that's weird, but that's also acceptable. A and B, they don't require anything, so they both branch off the starting point. Okay, let's say the top one is A. Again, if you say the top one's B, you're not wrong. And the bottom one's A, that's fine too, but let's keep it alphabetical. So A takes 8 hours. B here takes 6 hours. And it's good to have the letters above and below the lines. Okay, so A takes 8 hours, B takes 6 hours. Activity C requires A and B. So let's say this here is activity C. And activity C is 4 hours and it requires A and B. Now, what you notice is B finishes before activity A. So you've actually got a 2-hour leeway to dummy with. So this is going to be our dummy to C. Okay, because well, you don't need to label dummy. We just do a dotted line and we know this is a dummy. Okay, so activity B finishes before activity A, but that doesn't mean you can just move on straight to C. You need to wait for A to be completed. So that's why we dummy it like so, saying this 2-hour time off is us waiting for activity A to finish. Activity D also takes activity A and B. Let me just give me a second. Let me stare at this for a bit. Yeah, so because activity D requires A and B to finish, we can just draw one branching off like so from the same dummy point. Okay, because activity D also needs for both A and B to finish. And it can't just be B where it finishes and then you can go. So activity D shares the same dummy point connection and A connection point with activity C. So D here will take 5 hours. And so activity E requires both C and D to be finished. Okay, so this is a finish. That's the end. Activity E is 7. Again, we're going to have a situation where we've got 2 edges running to this point. So what we can do is, because activity C takes 4 hours, this one actually finishes quicker than D. So we can dummy this one away. We can go and, doesn't matter which one you dummy actually. But just for the sake of consistency, need to reconstruct this. So D connects straight to E. So we need C and D both to be done. But D takes 5 hours, so that takes longer. And then we dummy from C because, well, we've got an hour of spare time here. Okay, so we've got this dummy line. Since they don't finish the same time. That's a terrible arrow. We'll try and neaten that up. Okay, so activity C takes 4 hours. Activity D takes 5. Activity E needs both of them to be done before we can actually commence whatever the activity is. And so we've got 1 hour of chill time waiting for activity D to be finished. That's why we got this dummy path here. All right, so we don't start early, and then activity D is still incomplete, and then you don't have all the parts to complete activity E. Right, so it's a bit abstract when we don't have specific activities. Next topic, we will. So it'll all come together, I promise. All right, so for now, I think the easiest way is to dummy the one that takes a shorter time, okay, to show that you've got some slack while you're waiting for the longer time one to finish, so then you can begin the next activity, whatever it might be. All right, that's exercise 11.1. Do email through for any questions that you may have, and enjoy.